Hey there. So, where we left off last time, I was trying to figure out how to make this library thing work. And honestly, I still haven't figured it out. I have added one thing here, which I read in Stack Overflow. It says, hey, you should probably be doing this. Use test lib colon colon star. Okay, so fine. We'll do that. And so now I have both. Oh, and it rearranged them for me. Okay. I have both projects open. So here I have this other, the test lib project. Okay, and create type lib, blah, blah, blah. I built it. Failed to read cargo metadata. See, I don't understand that. Okay. So then I was looking, I was hunting further, right? So I've got an error there, which kind of makes me think that I built it incorrectly. Now, this kind of also says, so here, this looks very familiar. Now, one thing, my program's cargo.toml file, I have added the dependency following this answer. Okay, let's open in a new tab. Okay, and it says, I'm in a library. I want to use that library in a different program. What do I need to make this work? They're in the same project folder. Hopefully this makes sense. Okay. And this says, add a dependency section to your cargo.toml and specify the path, or the equivalent alternate toml. Okay. So, check out for cargo docs for specifying dependencies in total. Is there a way I can use the local crate myself for development while leaving cargo.toml referring to crates.io? Not possible by default at the moment. However, this is 2017. Okay. Yeah. So this is like, yeah. So I'm going to ignore that one. I'm going to ignore that one for now. Now what this says, and this is from 2019, a crate can be either a library or an executable, but not both. Your mylib contains a main.rs file, which means cargo will treat it as executable. You cannot import from an executable. You will need to restructure your code. Perhaps you actually meant for mylib to be a library, in which case you should have a top-level lib.rs file. So I kind of have a problem because I think last time I changed the name to testlib.rs, I think. So let's rename this to lib.rs. Okay. And what's the Rust analyzer telling me? Rust analyzer failed to read cargo metadata from cargo toml. Failed to run cargo metadata. No target specified. Oh, see, there it is. Source lib.rs. A lib section. So that's the problem. Okay. So this thing. So that was the problem, is that I changed the name of that. And I shouldn't have. Okay. So let me just build this now. Let's see if I can find the... Geez, it didn't build it. Cargo new test lib. Rust C. Oh yeah, there it is. Rust C. That's the one. Okay, and what did that do? Did that give me an error? Could not read testlib.rs. System I cannot find the file specified. Oh, wait a minute. Oh, right. Because now it's right. Okay, yes, because now it's not testlib, it's just lib.rs. Oh, now what? Rust C lib.rs. Okay, that did it. Oh, and I have liblib. It built liblib. Okay, I'm going to delete that one. Delete. Alright, so that's gone. So it's liblib. Now, okay, that built correctly, maybe, this time. So let's where's the copy? Copy. So I'm gonna liblib. Okay. Now, okay. Okay, now that copied that over to Rust modules. Now I can go to the other project. So let's go to the other project, this one with the main. And now it's just going to be lib. Lib. Okay, still it's saying use of undeclared crate or module lib. Unresolved import lib. But oh, there's lib right there. Let's delete that one. Okay, let me see if I can do it this. Lib equals liblib.rlib. Let's see if I can build that one. Oh, okay. Let's change directory source again. And let's see if I can do that. Nope. Unresolved import lib. Maybe missing crate lib. Consider adding extern crate lib to use the lib crate. Oh, okay. Sure. I would be happy to use extern lib crate. Let's see if that works. Whoops. Extern lib crate. Oh, crate. Extern crate lib. Okay, what's this? Now it's saying extern is used in two different contexts. Oh, right. Unresolved extern crate. Can't find crate for lib. Alright, let's cancel this. Let's try. Alright, now that we've done that, let's try using the up arrow here. And running this again. Nope. Extern location for lib does not exist. Lib.rlib. Well, it does. But, oh, but it's up one level. It's up one level from, because I'm in the source directory. So let's go /. Ah, there we go. So that sort of did the right thing. So now it found the library, and then it said unused import lib star. Oh, right, because down here I said lib : , right? And we found that out last time. that this is going to, let's save that and let's see if that works. Oh, and that built. And then if I do dot slash main, there we go, called testlibs public function. Yes, that worked. Okay, but I still end up with this. Oh, because create my inaccessible public function. Right, so there's a confusion. There's confusion. So I really should not use this one because I've got the namespace collisions thing. And instead I should use lib : oops, : and now I save that. Let me run it. Actually, I'll build it again. And then run it again. Okay, so that's better. So it's doing that. I'm not getting these errors, but I'm getting this still. So if I try to run it from here, can't find crate. Okay, is this where I need to do the cargo toml thing? Oh. Yeah. So let's, somebody dropped into the chat with one of those. How do I, we'll deal with you later. Okay, so, I'm just because you can't see it. See, it says, hey, I want to offer you a promotional for your channel, blah, blah, blah. Yeah, this is dodgy type, doge hype, whatever. Anyway, it's bullshit. That's what it is. Pardon my French. There we go. Okay, we'll just ignore that. I'll figure out how to get rid of it later. Okay. So, there. Oh, it ran though. Did it run? Run. Okay. For it's a terminal process, the originated terminal must be reused by task. Press any key to close it. It did not run, but it was waiting for me to press a key to stop. Okay, fair enough. Oh, and now only extern is highlighted. Wait, that's fun. Oh, no, now the whole thing is highlighted again. Okay, so would the toml fix it? Dependencies. Now, let me go find the syntax for dependencies. Oh, darn. Where are you? Where are you? That one. Here, dependencies, mylib, path, mylib. All right, let's copy that. And then back to here. And let's put that in the dependencies section, except this is now going to be lib is ./lib. It's up one level, right? Because I assume cargo toml. Well, I don't know. Is it based on cargo toml or is it based on main.exe? So we'll have to see. We'll try it in both places. Rust. All right, here we go. Rust Analyzer is complaining. What's it saying? Rust Analyzer failed to load workspace, failed to read cargo metadata, failed to run cargo, failed to load source dependency lib. Yeah, I know. You're unable to do that. That was the whole point. That's why we're farting around with this. All right, so let's go here. And let's run this again. Oh, no, okay. Failed to get lib as a dependency package of modules. Failed to load source for dependency lib. Failed to read c:/rust lib cargo.toml. Oh, you want to read. Well, that's not what I want. Well, I suppose, though. What's the other one called? What directory did I put the other one in? This one. I put this into the. What directory are you in? Rust testlib cargo toml. Okay, so if I say, because it's looking for that, so let's go back to the other one and let's adjust the toml. So where are you, toml? So it's up. Testlib. Yeah, and spelling. Doesn't like spelling. Okay, let's try it now. No matching packages named lib found. Location search. Rust testlib. Oh, did it put it into source? Oh, I think it's, sorry. Yeah, liblib is under source. Okay, so one more time. Let's see, cargo toml. So it's not testlib, it's testlib / source. And let's save that. And now, let's run that. Cargo.toml. Oh, no. But it was in the right place. It's trying to look for the cargo.toml. So maybe the cargo.toml for the library needs to have something in it. Because that seemed to be the right place. It's now the wrong place because it's looking for cargo.toml here of the library. So there must be something in that. So this guy's cargo.toml is looking in here. And do we need to specify library? Maybe we need to specify library in here. Or maybe we need to say that this is named lib, not testlib. All right, let's try changing the name first. Let's see if that makes a difference. Oh yeah, that's what it was. But I'm still getting these fail to read metadata errors. But it worked. Called testlib's public function. So it called the function. And it used... let me just delete this for now. Delete that. Move to recycle. Let me run this again. Yeah, it still works. Okay, so that means I don't need to copy things over. What I need to do is if I create separate projects for libraries and for applications, I can go into the toml and specify the location of the cargo file for that, the toml file for that library, and then it'll figure the rest of it out. So yeah, okay, all right, that's fair enough. I think I can live with that. I understand how that works. Okay, so the toml, we finally used the toml for something. We're able to specify that it's extern, and because it's in the toml now, we're not getting that error anymore. It was able to find it. So let's actually let's close this. I'm going to close this window, and then I want to file close the folder. Now open modules. Okay. Yep. And no errors. I'm not getting any errors from the Rust analyzer. So it's finding everything. If I run it, it's happy. Now, my question would be, what if I set a breakpoint here? Can I step in to the library? So debug, run and debug. Yes, 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 yes. Yes. Okay, then close it. I'm happy with it. Okay, so let's see. Step into F11. Oh yeah, look at that. Look at that. It found the file in the other project and was able to pull it in. That is cool. I like that. That's very nice. So that means basically my entire project, as long as I have source code for it, including all the libraries, it will allow me to debug everything. Awesome. That's very good. That's very cool. Happy with that. Okay. All right. 15 files. What have we done? Oh, okay. All right. Fine. All right. Let's commit this. Get libraries working. Okay. Oh, and I've got testlib here. Well, that's interesting. I have source. All right, let's stop this. Oh, this is interesting. I have testlib. Okay. Nice. Okay. So I got that and that. That's cool. Okay. Well, let's move on. Let us move on. What have we got next? All right, so we got figured out this using a library thing. All right. Attributes. Right, so we've seen these attributes before. That one that says dead code there, I'm kind of figuring what we're talking about. Okay, so attribute is metadata applied to some module, blah, 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 conditional compilation, set the crate name, disable linting, the warnings, enable compiler features, link to a foreign library, blah, 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 mark functions as mark functions as unit tests. Oh, that's interesting. I tell you, I have a real problem with unit tests in JavaScript. C#, much happier with them. Well, not a big fan of writing them, but nonetheless, it kind of works. But in JavaScript, I have this project that I'm working on, and I would like to upgrade to the latest version of all the libraries. I like to keep things, up to date, but I can't. And it's not because the library, my code would not work. It's because my tests don't work with the new versions of the libraries. It drives me crazy. That's causing me grief. Anyway, that's a side note. Anyway, when attributes apply to a whole crate, their syntax is crate attribute pound exclamation mark. When they apply to a module, pound. Attributes can take arguments. Okay, cool, lovely, whatever. So allow dead code. We've seen this one before. We don't need to really talk about it. Crates, crate type. Oh, I bounced into this last time, right? Because we had crate type lib, crate name rary. Yeah, whatever. Important to note that both crate type and crate name have no effect whatsoever when using Cargo, the Rust package manager. Cargo is used for the majority of Rust projects. This means real-world uses of crate type and crate name are relatively limited. Okay. Okay, yeah, whatever. Config. Config, conditional checks are possible through different operators. Config. Conditional. Oh, I see. This function only gets target. Okay, that's cool. Target OS, not target OS. Okay. Yeah. Cool. Is that it? Is that it? That's all you can do is target OS and config? There's probably other config things you're just not telling us about yet. Custom. Here we go. Some conditionals like target OS are implicitly provided, but, some like. So that means there are more than just target OS. But custom conditionals must be passed to Rust using the config flag, some condition, conditional flag, and then we can go config some condition. Okay. So we can we can set our own flag. So this is kind of C-like, where you could include things and not include things. You have your macros and whatever. So, okay. That's nice. Lovely. Now I'm not going to get to those for a little while yet, because we're going to be running just on Windows for the next little while. All right. Generics. Ooh, maybe we'll actually get to some code. All right. So we talked a little bit about generics. We kind of bounced down in here, I think, or at least we had a reference to it. Generalizing types and functionalities to broader cases. Reducing code duplication. What's this? A type parameter is specified as generic by the use of angle brackets and upper camel case. Generic type parameters are typically represented as T. In Rust, generic also describes anything that accepts one or more generic type parameters T. Any type specified as generic, generic. Okay, because it has been specified as generic type, it's considered generic. So here's an example. Right, we looked at this example already. Struct, there's struct A and there's struct single A. And then there's struct T. So this is considered the generic. And this, because there isn't the angle brackets, it's considered a concrete type. So single gen char. Okay, so it'll contain a char type. In 32. Okay, right. So whatever you pass into single gen, whether it's an A or a 6 or the character A, that's the data type that this is. So you can do things, presumably, this is only useful like if you're doing a search and you have, some common code, like I want to search through a list of a bunch of different things. And all the things have an ID in common, let's say. So it doesn't matter which kind of T it is, if the struct has an ID field or whatever. I'm not sure I'm using the right terminology here. ID element in it. Then you could search for it, because this example is kind of lame. But then the idea is that you can use that same searching code and just say, go find me the one I'm looking for out of this list or that list or the other list. And as long as they all have some common feature you can look for, then you can write the code once and use it against all the different lists of things. That's generally where I see generics being used in this kind of context. Sometimes you have two structures which are almost identical, but there's some differences, but you want to write the code that hunts for something in them once, or finds the thing, or sorts them by something that's in common, or whatever. All right, functions. Okay, so functions where you put the T there, then it's a generic. Lovely. Okay. None of that stuff is real surprising. Okay. Implementation. What's this? Implementations require care to remain generic. T must precede the type to remain generic. Impl T, generic val T. Oh, okay. So if I want to implement all right. All right, what's going on here? Sorry, I went quiet. So we implement genval of type T. Oops, sorry, didn't mean to reorganize that. But we had to specify this thing to say, hey, we're doing a generic whatever. So the idea would be that this is the implementation for val, right? And so we don't have to say the generic signature, the angle brackets T, in either case. And then this is always going to be a floating point number, and it's also always going to return the value, the floating point number. This one is, the genval is of type T, and this variable, see, that's the common variable that is of type T. And now I'm going to say, all right, so it's the same code. You'll see that pattern's the same, but this, we're going to return the whatever, that thing. Okay. Right. Okay, cool. So if we want a generic, we need to write it that way. Boy, oh boy, oh boy. Are we going to get to anything useful here? I'm looking at this. Honestly, I'm looking at this going, all right, hang on a second here. We've got implement traits, bounds, multiple bounds, where clauses. Oh, okay. There might be something in where clauses. Scoping rules, traits, macro rules. Now, I mean, honestly, we're going to get to the end of this, and I'm not going to know how to write any. I'm not going to be any closer to really writing any Rust code, am I? I don't think I am. All right. Well, let's. You know what? We're more than halfway through. Let's just plow through the rest of this, and then maybe move on to some other place where maybe I can actually learn something more about writing Rust code. Traits can also be generic. Trait double drop T, double drop TU for U, blah, blah. Oh, by the way, this is the one thing. This is a same syntax as C#, where you can specify a list of generics separated by commas. And then, so if you're passing in a T and it's returning a U, then, and this method takes ownership of both passed arguments, deallocating both, double drop, self T. Define a method on the caller type which takes an additional single parameter T, does nothing with it. And Caller you. Oh, caller for you. For you. Okay. So empty is empty, null is null, double drop null, empty dot double drop. So this is going to what? Wait. What? Oh. Okay. Got it. So we have an empty struct, we have a null struct. We have a trait called double drop, which has in it a function called double underscore drop. And then we have an implementation of double drop. Okay, sure. So we created a trait, said, hey, this trait has a double drop. Then we create an implementation of double drop, which basically does nothing. Okay. Now, this empty null, deallocate empty and null. Empty dot double drop null. Now, why? Oh, okay. So, non-copyable types. So they're non-copyable types. We pass them in, and because we take ownership, this is what it's saying here. This method takes ownership of both passed arguments, deallocating both. So because we've taken ownership and then we toss them away, then they're gone. Okay. That is going to be hard to remember. That's going to be hard to remember. Okay, but we don't want to take ownership. So I think the bottom line here is in these implementations where we want to kind of do something with something, we want to borrow it and then return it. We don't want to take ownership of it. And that ampersand, I think, is how we're borrowing. So indicating that we want to borrow. So, all right, so this is, so I know this isn't what they wanted me to learn from this, but I am going to copy this. And I'm going to create a new project here because I want to understand this borrowing business better. So file, close window. Oops, I probably didn't want to do that. It was my last window. There we go. File, close folder. File, terminal, new terminal. /rust. Cargo new. Generic trait. Okay. And then file, open folder, Rust, generic trait, select folder. Okay. Source, main, select all, Control A, and then paste. All right. So now, if I run this, let's just make sure this works first. Run. Yep. It did it. If I uncomment this, save that, I get errors because empty is moved due to this method call. Null, move because has type null, which does not implement the copy trait. Okay. All right. So if I were to say, if I did ampersand t, ampersand u, no, that doesn't do it. No, it's got to be t and u, I think. Ampersand self. Change the self-receiver type for ampersand U. I don't know what I'm doing here. Nope, don't know what I'm doing. Oh, but I suppose maybe this one? No, that's not it. How about ampersand self? Oh, now it's happy. Oh, right, because this one defined what it was, and this one is the implementation. Okay, and now empty is not complaining because I borrowed empty. I did not borrow null, however. What if I passed in ampersand null? Oh, and what's this? Path statement with no effect. Why is there no effect? But it was happy. Oh, because it was the last line. It was complaining about that. Okay, so if I do the ampersand null business, okay. Let's see. Print line. Oops. Empty. Oh, well, let's see. What's this? What's it complaining about now? Oh, empty does not. Alright. Oh, how about then I do the debug thing? Colon question mark? Empty doesn't implement debug. Well, geez Louise, just do that thing. Struct. Alright, fine. Not empty. Fred. Oh, I can't remember. Equals? Colon? That's not it. Comma. And what's this? Remove this semicolon. Okay, so I have a not empty struct. So we'll go not empty. And then, oh, what's this? Oh, right. I need to initialize it. 5. No, curly brackets? Right, I gave it a name. No, that's not it. Expected colon, thank you. There we go. No, it's, because, you know, in C# you would use equal signs. In JavaScript you use colons. And here we're using double colons and not colons and, I don't know. What's this? Not empty does not implement debug. Why not? Oh, right, because I need to say something about debug. There was that. What was the syntax for that? All right, let's go back to way back. Sorry, I'm going to look over here for a second. Back to basically the earliest print. There, derive debug. That one. Okay, now, are you now happy? Borrow of moved value empty. Yeah, but oh. Right, because it was the null. Yeah. Okay, what's this? Oh, value moved here. Okay, let's not move it there. Now what? Path statement with no effect. Okay, let's comment that out for a second. All right, are you happy now? Let's run this. Nope. Oh, what's this? Field Fred is never read. Well, yeah. I'm just fooling around. Okay. Here, we're going to turn this on. Right. Okay. So, fine, whatever. We're okay with that warning. We should turn on the dead code thing to allow that to not give us this warning. It's generally a good idea to remove all your warnings. So there was this C# project I was working on recently, and I inherited something, and it had like 600 warnings. And 2 or 3 of those warnings actually were meaningful, and the rest of them were just, stuff. And the problem is, when you see this wall of warnings, you don't know. And you just, in your eye, it's so hard to find the ones that actually are meaningful. And so you just ignore all of them. So it's always a good idea to clean out all of the warnings, because then when you do get a warning, it actually means something and it's important and you should deal with it. But when you get lazy, and like this, for instance, I'm getting lazy here, and I ignore that warning, and I don't put in the right flags to say, yeah, it's okay, don't worry about it. Then if I do get some other warning, now I have to scroll around, right? Because that window is kind of small, and there could have been something up here that was a real warning that I actually cared about, and I would not have seen it. So, do yourself a favor and always get rid of all your warnings. All right, so what I did here was, the original code had empty and null, and it assigned, them, and then did this double drop thing. But what I did here was this is weird, a little weird, because this says it's double dropping, right? But then here, because I called empty.double drop, it didn't actually drop empty. Now that's the thing I'm trying to figure out. I get that why it didn't drop null, because I passed ampersand null, so then this, and then ampersand self, and then it's okay, it's just a borrow. But why was empty borrowed and not consumed? Just because I made it not empty. I don't understand that, because I didn't change anything about empty, because this is for you. So empty is the U, null is the T, right? Because I'm passing or maybe not. All right, let's run this again. I'm curious. Da, da. Oh. Oh. I don't know. I don't really understand. But if I hadn't passed the ampersand null, now this is an error because it says, hey, we've moved null in here and then they got dropped. It's actually dropping it. So fair enough. That one I get. Ampersand, I'm borrowing. I still get to use null. Although I'm not doing anything useful with it. But empty, why did empty change from being dropped to not being dropped just because I created... Alright, let me do another one. Let me go back and say struct, whoops, not string, struct empty. Yeah, I know. I'm getting there. Not, shoot. We're going to get complaints. Empty. Not empty. Not empty. And then we're going to say let empty equals empty. And then we're going to say empty dot double drop null. Oops, wrong place. All right. Oh. Oh. Oh, what? Okay, this is interesting. Borrow of move not empty. Value borrowed here after move. So this is a move. Interesting. And that's a move, right? Because I think that's going to give me the same error. Yeah, use of moved value null. How is that a move? That's weird. Just the thing by itself on a line is a move. Okay. All right, and what's this? So this one I can't use. Use of move value null. But interesting. Oh, hang on a second. But empty. Oh, is it because of the ampersand self? So this empty also, no, so it wasn't this. It wasn't the fact that I created a struct with something in it. The difference was the ampersand here and self. But why is self? Oh, self is a U. Oh. Oh, okay. Huh. So if I did, so when I do this, no, that doesn't make any difference. All right, so if I delete these, the ampersands, to go back to what it was before, so then Now, right, not empty is a complainer, right? Because it's been moved. Okay, so not empty has been moved because the U, the self, referred to U and not T. So there's a T referenced here and a U referenced there. So if I had said ampersand self ampersand T, ampersand self ampersand T, can I do that? Are you happy? Looks like you're happy. And then this, oh, and I need, so now I need to pass in an ampersand null. And now the null works. Nope, doesn't, because that's still a move. And the not empty is being moved by that. Now that was weird again. So, okay. Now these are, yes, these are warnings. Hey, they don't have, like, you've got code with no actual usage. Okay, cool. So, okay. So I can, if I want to borrow ampersand whatever, if I want to move just the name, and then it's gone. It no longer can be used up here because it's now the ownership is transferred over to this implementation. Got it. All right. I think I'm understanding this. I think I am understanding this. Ha! There's a surprise. All right. Let's move on. Where are we? We're here. Okay. Bounds. What's bounds? Bounds. When working with generics, the type parameters must often use traits as bounds to stipulate what functionality a type implements. For example, the following example uses. For example, the following example, you really shouldn't put example right next to each other. For example, the following uses the trait display to print. And so it requires T to be bound by display. That is, T must implement display. So here we say T colon display. T, lowercase t colon T. Okay. T. Bounding restrictions, the generic types that form the bounds. Okay. All right, that makes sense. Oh, here we go. Another effect of bounding is that generic instances are allowed to access the methods of traits specified in the bounds. Oh, okay. So then, because I say debug, I can, okay. T must implement has area, and any type which meets the bound can access has area as function area, t.area. So that means that because I'm saying this has a has area, oh yeah, that T must implement has area. Okay, that's nice. So that now that's kind of rounding out the picture of these generics. So you go, okay, I've got this function, it's or this function, it's going to be generic, but I'm expecting a has area. And because I know it has a has area, I can, I don't know, do the sum of all areas or something like that, right? Right, does not implement either debug or has area, so when we go do the print, it's the triangle's not going to work because triangle is a triangle. But if we implement has area for triangle, then we're going to get what we want. Okay, fair enough. And that's a where clause. Where's the where? additional note, where clauses can also be used to apply bounds in some cases to be more expressive. There's where clause down here, further down. Okay, test case, empty bounds. Consequence of how bounds work is that even if a trait doesn't include any functionality, you can still use it as a bound. And copy are examples of such trait from the std library. Okay. We have trait red, trait blue. Implement red, implement blue. That is no implementation, but it's just we said we did. So now we go function red, function blue, cardinal blue jay, turkey. We go turkey is a red, and that's going to be an error because red has not been implemented for. And if we could say implement red for turkey, and then it would work. Cool. Multiple bounds. Plus sign. Ooh, plus sign. Okay. Debug and display. Okay. Nice. Where clauses. Again, this is stuff I'm not going to remember. But bounds can be expressed where clause immediately before the opening curly bracket rather than additional where clauses can apply to arbitrary types. Where clause useful when specifying generic types and bounds separately is clearer. So, okay. Implement A, D, my trait AD for your type done, expressing bounds with a where clause. AD, my trait AD for your type where A, D. Okay. Yeah, I get it. This one looks easier to read because it separates them, the different things we are defining from which traits belong to them. Okay. When using a where clause, more expressive than using an implement cannot be directly expressed without a where clause. Oh, something that we can't do. Where, option T debug as our bound because that's what's being printed. Doing otherwise would be using the wrong bound. Function. Oh. Okay. Oh, we're in the where clause, we've got option. Because that didn't happen up here. It was just A. Here we got option T. Interesting. Okay. All right. Again, I'm not going to remember this. New type idiom. The new type idiom gives the compile time guarantees that the right type of values is supplied to a program. For example, age verification function checks the age in years must be given a value of type years. Struct years, struct days, implement years, implement days, old enough, and we want years, ampersand years. Age is years 5, age days 2 days, age to days to years, and then we just grab age days and it's going to go, nope, that's not good enough. Okay, all right, so I see the advantage of, yeah, okay. I thought this was like a type equivalency. You know how we did those types? You know, in 32 equals years or something, but that's not what we did here. We created a struct called years, which contains just, okay. So it looks like to me, like whenever we want to name something, we want to create a struct for it, even if it's just a single value, like a simple value. And then we can do some implementation on that single value, and we can do some, but this is the most important part, is this business right here, where we say, you got to be passing me years. So that's going to be a nice benefit of that. Okay. Okay. Not sure what that was all about. Associated items. Associated is a set of rules pertaining to items of various types. Extension of traits. Okay. Alright, you know what? That's quite enough. We'll get to the rest of that next time. Alright.